Welcome again, everyone. As always, the notes are posted on the Slack channel. There's a pin at the top there. Add yourself and the quick reports. They're also getting to the point where I might just be randomly calling on people, seeing where people are at concerning it at that kind of time period, or at least in numbers of people right now is kind of manageable. As far as agenda and announcements, Lindsay, I know you made a mention about the newsletter going out. That you're assuming you're always are wanting information about what people are up to with SimPEG on there.
Yes, absolutely. I dropped the link in in Slack, but I can pop it in here too. And the talk this month will be Craig Miller. And so the date we have, let me just look, but I believe it's the 19th, it's a Friday, is what worked best with him. And it's at 3 p.m., I believe, just double checking. Yes, it'll be the 19th at 3 p.m.
Other big announcements, or we're just getting a quick reports and kind of go through it. We'll get to everything. So I have been, some of you guys might have gotten pinged a little bit, but one of my students submitted a pull request to the GPG to fix a few typos, and I thought it was really neat that they did that. It was really neat to see that. I'm like, oh, okay, yeah, that is. But I think we got that link fixed up. What was the computation that GeoSci.xyz, what was that doing?
We started that a while ago. The vision was to have sort of like a resource kind of on finite volume, on inversion. And we put a few examples and things like that in there, but we never really, we haven't maintained it. And so I think there's good stuff in there. We shouldn't delete it. But I also don't think that it's in a state that we want to be referencing, pointing too many people to it.
I've also, John, now that you guys, it seems like you're getting really close to this pull request, I've gone back, that might head back into the MT with the bounded side of it, so get everything working again, because I think that's still part of the PR in there. So,
sorry, which one?
So the bound, the new 1D implementation.
Oh, the 1D boundary, yeah.
The 2D bounded problem. I've been revisiting that and trying to get it, push it through now that you're pretty close. So that should help with some code coverage on that.
Right on. Thanks, Joe.
Just finishing hooking up the receivers and testing derivatives. That's it. Yeah. Should be good to go.
Right on. Oh, that's awesome.
Yeah. I made the receivers in 1D be a little bit more flexible for those, at least for those PDE ones. So the 1D receivers should be able to support both orientations instead of just one of them before.
Yeah. Nice.
Just double checking by my estimate from SimPEG with the 1D Earth of the XY impedance should have a what was it, like a 100, like a negative 130 or something, negative one. Should be a negative value instead of 45 degrees, right? Because
45, yeah.
the SimPEG, it's YX, I believe, was 45 degrees.
That one.
XY was like the negative, so 40, whatever 180 minus 45 is. Was that what you remember as well for a 1D Earth?
As far as I remember.
I think it's a little bit backwards, but it's still in line with what SimPEG's definition of coordinate systems are.
There was one other thing that well, we do have tests for the rho and the apparent resistivity and the phase for the XX and the YY. But like you showed before, if you just change the model a little bit, it blows up the YY and the XX because they're divided by 0. I guess it's an offset, or is there something that might be a little bit too dangerous, I guess.
Oh, like to kind of stabilize those derivatives a little bit?
Yeah. Or just have a more, yeah, fair enough.
I think the stabilization could probably come in with like a noise floor.
Okay, yeah.
Maybe.
Yeah, generally I apply a floor uncertainty on the diagonal components, and then more of a percent driven on the off diagonals, and that seems to be fine.
Oh, that does? Okay, perfect, cool.
Yeah, I think that's sort of what I've advocated for as a best practice.
Yeah, okay.
Okay. And then I've also been applying the cross gradient regularization that I was working on to a few more models. It still seems robust to those like checkerboarding issues that could have happened before, so I haven't really been encountering that in any of the examples I've been running, which is good. Even with like a really high regularization on the cross gradient, when it gets enforced really hard, like I can see that checkerboarding issue. So I'm getting a little more I'm getting more confident in it. However, I will still need to spend more time updating some or automating some more directives. The way that those parameters that enforce the cross gradient are controlled right now, there's no directive to kind of update it or adaptively increase it or decrease it if as needed, which can make it a little bit harder to optimize. So that's also what I've been working on. So thinking about some of those directives to kind of automate the cross gradient. So that's what I've been up to. John, how's it going on your end?
Not too bad. Yeah, the last week there, we pushed as much as I could there on the MTPR and everything but that one test, and then the 1D stuff there. But it looks like you've got that all wrapped up. And yeah, I decided to look back at the DCIP processing code because, yeah, it's just time for an update. And yeah, I've kind of generalized it enough that I can probably push something to the SimPEG side again. Hopefully have some examples. Someone can have some fun with it. It just the pure stacking, just give it a time series and you can do your windowing, put whatever stacking kernel you want into it. Yeah, just some stuff that someone wants to play with. Yeah, and then yeah, I want to give a talk on the on the parallelization of the inversion there. Finally got some hard numbers and some good graphs, and yeah, for doing large scale inversions, getting some good results, or getting results back, but I just need to run some inversions now with the larger scale data. Yeah, I'm finding that pretty much when you get to large scale data, you have to mesh, you have to decouple the mesh. You can't just send a global mesh to everything and give it fewer sources and expect to get a good speed up. Like with 10 million cell mesh, if you give it 340 sources or 20 sources, you get maybe a 10% speed up. It's just too large. So now I finally got some hard numbers so I can get my boss to let me go to the mesh decoupling now. And yeah, I just wrote some stuff for the tensor decoupling. Yeah, it seems the octree is definitely going to be the better way. You're going to save more, but the tensor you actually do save quite a bit, even if you decouple a tensor. It's significant enough. But yeah, hopefully either December or January, I'll fill in one of those talks there and we can show my results. And that's about it.
Okay. No one else has put on anything. I can go around and ask people.
I've got a question.
Sure.
Do we currently have any capabilities in SimPEG for estimating volumes based on a cutoff? I know some of that work was done with the CAMP project, But do we have that in SimPEG, or is that elsewhere at this point?
I don't know of any in SimPEG. It just, like, I want to estimate the volume of properties between this number and this number.
Yeah, yeah. And potentially within a given sort of bounding box, so that if you have stuff in the padding or something like that, it's not included.
Not that I know of.
It depends if you want to make sure that they're connected or not, right? If you want to identify separate bodies, because otherwise it's easier. Right? You just do a threshold and a value and get the cell volumes. But yeah, if you want to identify isolated objects, then it's a little bit more of a search problem, right?
Don't you think you could do it in PyVista?
I don't know if PyVista has the capability. What do you know of their functions, Peter?
I just know there you can plot relatively easily bodies depending on a value, right? So you can have a threshold.
Yeah, sure.
And then by defining two thresholds, I guess you could potentially see the volume in between. I'm not sure.
Yeah, no, that's easy to index, right? To just do like anything like larger than a value, give me all the indices and then get the volumes from that. But I think what Lindsay wants to do is to say, this body and that one, what's the volume of this guy, what the volume of that guy?
How was that done for the camp project? Do you know?
Yeah, well, initially we did like we put a seed and then you look at neighbors, right? And it's kind of like a propagation function. But it's very expensive, and eventually, as you said, like if your body like is close to the edge of your domain, then you start like bleeding into like larger volumes, which then you need to threshold it. So at the end of the day, it was just more efficient to do a bounding box and a thresholding, basically. Yeah. What's your problem, Lindsay? What you are trying to do?
Well, thinking basically about exactly that problem
Yeah.
is estimating volumes for carbon mineralization.
Yeah.
So either from an L2 or LPLQ inversion. Yeah.
Put up like give me around this point. What's the volume type of thing? Yeah.
Yeah.
Oh, hey, Tivo. Tivo, do you have any quick reports now that you're here?
No, sorry for being late. I just ran into Mark, and it was good to catch up with the volcanic and planetary science group. Sorry for that.
Oh no, all good.
But not much quick report. I'm mostly been writing rather than coding these days.
Dom, is that code kicking around that you used for that? Is that something? I mean, because we could think about like trying to clean that up or at least have a first cut at it in SimPEG.
Yeah, definitely can make it better. Yeah, I have a notebook somewhere. Yeah, it definitely needs love. It was pretty brute force. It kind of reminds me, Joe. Ideally, you would have a function like on the mesh in discretize to be able to access all neighbors of a cell, right? And maybe that lookup function would get a lot faster if we be able to do that.
Yeah, I know we have something like obviously the tree mesh, you can look at the neighbors of a cell, but and then in a tensor mesh, we know the neighbors of the cell by definition.
Yeah. Yeah, it's the old issue of not these neighbors, but also the cross neighbors, right? Yeah, anyway.
And Thibaut, you did some of that for the geologic segmentation abstract, right? Like
well, yeah, but because I was looking for like a certain number of neighbors and so on, like I just basically there is a KD tree behind that I'm building with SciPy. So I'm not actually using the property of the mesh. I'm building my own KD tree for each geological unit.
Okay.
Yeah, and the problem with KD3 is just a distance measure, right? So if you're in an octree mesh, if you have a octree change, you might not see the big neighbor next door, and then you miss it. That's why
Yeah.
using the discretized package is better, because then it's really a connectivity between two cells. Anyway, we can work on it. I'll send you what I have, Lens.
Thanks, Tom.
I know I had written something somewhere to estimate, and not necessarily estimate volumes, but just look at for sensitivity analysis on a tree mesh, looking downwards from the top to find a sensitivity cutoff.
So you go down and
Yeah, that one's a little bit easier because you're just looking in one direction the entire time.
actually, Lindsay, now that I think about it, maybe the easiest would be to use the marching cube. The scikit-learn has a to create isosurfaces. There's a marching cube algorithm. It's pretty fast. So maybe that could actually be a better trick. I'm using it to create isosurfaces, like surface isosurfaces. So maybe there's a way to leverage that package.
That's a good point. We'll check that out. Yeah. Thanks, Tom.
Okay. So other than that, how about anything else you've been up to, Dom?
I've been working on IP a lot, doing 3D IP inversions. Try to manage to do the parallelization on that part. It's fairly easy, right? Because it's linear. So the speed up is really nice when we store sensitivities and block it. Now I'm looking into. I realize that a chunk of time is being used at evaluating the data, creating all the projection matrices for all the receivers. I know that you did mini surveys, Joe, to be able to reduce on the transmitter side, right, on the source sides. But we still do 2 for loops, which is, just creating the survey initially takes longer than creating most of the rest of the mechanics. So I have the feeling that we should probably have a survey evaluate rather than evaluating all the receiver sources. Just create a giant projection matrix basically for all the receivers, right? I don't know why we're doing it like one at a time, where we could just create one bit projectors from field to all the data. I don't know what you guys think about that.
I mean,
but yeah,
Sorry, Joe.
It's another level of optimization. It's just storing like just storing a projection matrix for each electrode and then sending it out from there.
Yeah, but when we do the query on the fields object, right, we could just do it on a one operation rather than doing a for loop over all sources, all receivers. That's like super heavy in Python. So I don't know, just a thought.
What would be the cost of storing all that?
Well, it's a sparse matrix, right? I mean, it's a sparse matrix that just goes from nodes or cell centers to a point. So technically, it's like 4 integers per data points, 4 or 5 integers per data points or something. It's not. I mean, we're storing it anyway, right? Because we're just storing it per receiver.
How many receiver objects are you creating? Is it more than one?
Yeah. I mean, receivers, like on a DC IP survey, right? You could have like thousands of receivers. So then you're doing a for loop over thousands,
But they should, it's sort of one receiver object with all the locations, or are you giving each receiver only has a single location? This is something that is slightly confusing in our terminology.
So maybe
basically, as long as you're either working with either a pole or a dipole receiver type, it can take multiple locations. So
you're right. Yeah, it has multiple locations. Yeah. So why? Huh. Yeah, that's a good point. So maybe because I have many sources. Yeah.
Like if you only have like one receiver for one source, like everything is paired up like that, but that kind of breaks it down.
Yeah, fair enough. Yeah, maybe I would just have many sources. Yeah, if I have like a big dipole survey, you kind of going over several sources, right? Still, you could still have like 100 sources type thing. But yeah, I see which point. Yeah, it's true. All the locations are stored under one receiver, which is confusing terminology, but yeah. Okay, well, I don't know. I'll have to dig deeper later. It's not urgent. It works. Inversion works, so that's all good. And then, oh yeah, Joe. So we have this pull request, right? That is in front of Thibault's PR. So I addressed your concern. Maybe do another round, and then we can merge it in.
It looked like it was all passing, but my only concern was one of the tests was taking a lot longer than it is normally. So I was going to look at what was causing that. I think it's just a slight difference in a convergence or something on an inversion example.
On 1037, you're looking at the runtime. Okay, 60 minutes. Is that the one you're talking? Okay, well, I don't know. Yeah, can't help you on that one.
I know. So I was like, I just needed to look into that. That was the only thing that I was looking at.
Yeah, because after this, it's Thibault's 1053 that we need to go in, right?
Yep.
And then we can carry on the rest of the work after.
Like all the tests passed, everything was good. It's just that one took an hour when it normally takes probably about 20 minutes.
Did I even touch at that part of the code, or it's just a pipeline problem?
Well, it seems
It's
like
one of like it's the tutorials, like it's running the tutorials, I think, a couple tutorials.
so. It might be that because now I'm just thinking like now that you normalize the weight by the volume, like if any of the example or tutorial is using the simple regularization, they should now use the Tikhonov. Will that be the difference?
Well, it should be about the same now. They should be the same. The only difference is I'll have to look into it a little bit more, but that could be something. Yeah.
I don't know.
Like definitely with your change DOM, like the PGI example, we need to switch from simple PGI to PGI. That's a certainty already. So we can, at least in the example in tutorial, we can just like replace all the simple PGI documents by PGI, and that would fix that. Like I did it on my branch, but maybe we can do it. We can do that specific portion and.
Yeah, I look at all the tutorials, and I don't think that's referencing simple anywhere. It's either Tikhonov or sparse, so I don't see why would that change anything. But
so if they were referencing Tikhonov before, and now it's and they were using an updated sensitivity weighting, right? Some of those tutorials might have gotten double volume. Like they might have been double volume estimated before, the volume term before, now they're not. So just causing slight different convergence. I just need to go back and look at it and check.
Okay.
But yeah, I just double checked. It's about 30 minutes. It's like that one test takes about 30 minutes now. And like you said, it was about 50 minutes there. So I'm pretty sure it's just a convergence thing.
Yeah.
So you do it? You're gonna do it, Joe, or do I want me to do it?
I'll look into it.
Okay.
Peter, what have you been up to the last 2 weeks? Or 4 weeks, or however long it's been?
Not much, 4 weeks, I think. Long time. I was at a physical conference, which was kind of a new thing in the last 2 years. The EIG in Amsterdam.
Oh.
That was kind of interesting. It was quite small, and there was a dedicated small group that followed all the non-seismic stuff. You after the first day you knew each other, and then yeah, you stuck together. It's quite a small group, but yeah, it was nice to meet people in real life. Yeah.
Any
But other than
interesting?
that, not too much. Anything interesting? Well, everything is joint in some degrees, right? You don't see hardly anything only EM, let's say, or only MT. Slowly getting dominated by machine learning stuff as well. So I guess the usual. Yeah, there was the one by Ramco, by Daniele Colombo and Rovetta. I think they published in Geophysics this year. They do this joint inversion, where joint means deterministic gradient-based inversion with machine learning inversion, which I found very interesting. So using the advantages of both to get to a hopefully global minimum. That was kind of interesting to me because I never thought of it or heard of it. So that was kind of new.
Yes, I have a publication around, like I saw they were at SEG as well, but yeah, like the detail of the implementation was eluding me. It sounded quite complex compared to. They were trying to constrain the machine learning by the physics, but it was, yeah, I was not sure how it was running.
Let me. I'll put it in a chat. The article. I think it's Geophysics this year. I'll have to look. But I would assume that it's not straightforward because you kind of, well, as usual, I guess the weighting will be the difficult part. How do you combine these two? I haven't looked in detail. But yeah, how is this 1 week going? The new scheme. What is it? A month now? A month and a half?
It's been going for the last month, right? And then today, yeah. We don't have too many people joining from New Zealand, Australia time zones. Like that.
Well, neither from Europe, so it's. I guess in either time zones, it's only 1 or 0 person joining at the moment, right?
Yeah. So, but I mean, it seems like it's working out okay for the Vancouver crews. Just a matter of getting back into reminding, like, oh yeah, today is a 4 or 3 o'clock meeting versus a 10:30 meeting.
Yeah.
Seems like it works out okay.
It's good. I think it's nice. It's just this danger that if you miss one, then you miss a month. But then on the other hand, a month passes quick, as we know. So.
Any other things you'd like to chat about?
Maybe one quick thing. So as I go through the API stuff, I realize that there's the properties package is still very much alive in SimPEG. So, I mean, we don't want to put too many things into one project, but they do kind of go hand in hand. So I think I'd like to confer with you at some point on how we can exercise the properties and that I can continue on. So yeah, I'd like to do that before I start messing around with things too much. Otherwise, I'm not really moving through in kind of a methodical fashion.
Gotcha. Yeah, it does make like we need to put that forward if this is going. I even still looking at it, I don't think properties is that like it's not that hard to get rid of properties out of SimPEG. It just takes some work.
Yeah, I don't think it's too heavy, but I mean, you already went through and did it for discretize. So I mean, even just kind of if there's any little detail that I'm gonna miss going through it the first time, or sort of yeah, just to be consistent with how it was done in discretize is kind of what I want to accomplish.
We just need to do it for one class, right? And then we can just do a small PR just for one of them, the easiest one. Pick one, any, and then we can all comment on like how we're moving from stuff from properties to with the setter. And then after this, copy and we just go one class at a time, and then change them.
Yeah, that actually makes sense. Just do it on a separate branch. And then, okay, so really that's kind of the first step then, is exercising properties before we would even, yeah.
Yeah, do
Yeah,
it one
that's
class at
why-
a time. Yeah,
That's why I'd
Yeah.
recommend it, like starting with the API stuff, starting with all the functions and those things, like documenting those, because those are not dependent on that, right? Those just kind of build by themselves nicely.
Yeah, I mean, I guess I was starting the documentation from the base SimPEG classes because so much work is being done on individual simulations. There was also projects being done with regularization. So I'm trying to, I guess I was starting with the stuff I felt was not actively being changed by the community, sort of where I started.
well,
So
those
I think-
functions are technically not being touched too much, right? All the utils. Yeah,
Oh, the utils are already documented.
okay.
And there's no properties class in there, right? They're just, they're functions, so they're
Yeah,
not
that's why-
properties class.
Yeah, that's why I said that those were like the easiest place to start.
Yeah. So
Yeah.
that's already done and built locally. So now I'm moving on to SimPEG classes. But yeah, I like that idea. So I'll start a branch for exercising properties, start somewhere small, and get some feedback. So that would be good.
Or even create a branch that is like exercise properties in this class, right? So then we, or a module, maybe can do it per module, but
Yeah.
so that way we can only like, refactor this part, merge it in, everything passes, and then switch to the next one. Don't try to do it all at once because it's going to be a mess.
Yeah. And then I'll just, when I'm ready for each small piece, I'll just tug at people's shirts.
Yeah, I've worked on the regs, so don't do the regularization. I'm already on it. Just do something
Yeah.
else.
My other question is, so in Discretize, it was, I tried to keep the serialization side of it still alive. How often are we serializing SimPEG classes? Like, how often are people doing that?
It would be, we had that idea in mind, but we never actually got it materialized. So at this point, I would say just
Don't worry about it.
don't worry about it and we'll fix it later.
I mean, because most of the SimPEG classes, I've never tried pickling them, but I imagine it would work.
You can pickle a mesh.
Yeah, I know you can pickle meshes and you can pickle things, but
Like the Gaussian mixtures also is very easy to pickle.
Yeah.
You can pickle that. I actually do that a lot. I create the GMM in one notebook, pickle it, and then import it.
like it's not readable, but
Yeah, but I think often you will run into issues if you then update the version of SimPEG and try to load it something from half a year ago. It's likely to.
so I imagine it can probably be one of the things where we keep it on the back burner. Like it's still not. I think we could probably be safe with just removing properties and not worrying about trying to implement the serialization side of it right now. Because that adds a whole nother level of things we've got to care about.
I agree. Yeah.
Agreed.
I missed that you completely removed it from Discretize, 100%.
So
Joe.
properties?
Mm-hmm.
Yeah, that was a while ago.
Right. Cool. Yeah, I knew you removed it. I thought you removed it in many things, but I wasn't aware that it's completely gone. Okay, cool.
Do you have an example of something that's not pickable in SimPEG right now? And why that's not pickable?
I have not. I mean, most things.
I bet the fields object won't.
Yeah, I don't know, but no. So things that are not pickleable are like nested definitions of functions. Lambda functions are not pickleable. Things that basically functions that only exist at runtime. And I don't think that really occurs too often in SimPEG.
One quick idea that I'll throw out there and we can see what folks think. I wonder if actually starting, Devin, if you started in GeoAnna, if that would be a simpler place. We've got properties in there, but it's not super heavy. And I suspect, and I don't think we're doing anything in terms of like observing objects or things like that. So removing it there, I think would be probably much more straightforward than SimPEG, and would give you a better feel for, well, would give you a feel for it without, before sort of tackling the complexity of SimPEG.
Well, I do already have discretize as kind of my example for how that was done. And I would say that I guess my ultimate goal is to finish the API for SimPEG. So I don't really want to be diverted from that goal. So yeah, I mean, if everyone thinks that's probably the best idea, I could go through it, but yeah, I feel like the quickest way to attain my goals is to start with something simple in SimPEG and just get feedback from there directly.
Okay, I mean, I think either is fine. Then if you want to start in SimPEG, then I would say start at the top. Don't start at the base. Start somewhere like DCIP or EM. Start at the top and work down. Starting at the bottom is always harder because you flip something and everything else kind of falls on top. So yeah.
Well,
It will all have to be done at some point anyway. So
Yeah.
any
I
work
know-
done is
I know when I did it to discretize, I did actually start with the base class and move outwards, but then I did it all at once. So
Yeah, I think.
and you're
that-
and you're the god
first
mode of
SimPEG-
discrete.
Yeah.
Sorry, Linz.
Yeah, no, fair enough. I mean, I think for SimPEG, I would highly recommend that you start at the top. I think if you start at the base, this is going to be a much harder project. So.
Yes, start out with something that doesn't have any dependencies, or that is not a parent class of a bunch of stuff that will. That's a pretty good idea. So.
Yep.
Okay.
okay. Anything else? Anyone feel like chatting through?
How is the tetrahedra stuff going, Joe?
Oh, it's getting there. Just
Cool.
working on a few other things at the moment.
When can you show it off for Christmas event
Sure.
with SimPEG
Show it off for
tetrahedra?
Tetrahedra Christmas tree.
Yeah.
That would be cool.
But it is giving me thoughts on how we're designing some of the internal functions, because the way some of our PDE is constructed, they involve in inverting the mass matrices. If some of our formulations in SimPEG involve inversions of mass matrices. And that is not an easy thing to do with the tetrahedral meshes, because those mass matrices are all often like irregular sparse matrices. They're not just diagonal things. So the tetrahedrals only work with certain simulations. So like they'll work with the nodal DC formulation. They'll work with, I think, the electric field formulation. I have to double check, but there's only a few ones that will actually work with. And actually, also a few different types of receivers too, because some of the receivers and fields are implemented with inversions of mass matrices. So that's been something that's been on my mind, thinking about that.
Cool.
I want to have a Christmas tree and then do a DC experiment, and you put power at the bottom of the tree, and then all the light bulbs light up and it fills. That's what I want for Christmas, Joe. Code it up, man.
If you wanted to, do you know the solutions for like the potential field solutions for tetrahedrals? Do you know where to find them?
Like it's a question?
Yeah, do you?
No, I would have to look for it. No.
Well, if you get bored and you want to start coding up like that solution, that would be nice too. So it works for the integral, the integral equations in potential fields.
Yeah.
If you feel like it.
No, but I know for sure that the one with where it's like you have some faces, but just the tops that are curved, that one was, I've seen it, but not for a pure tetrahedra. So I don't know. I know
it's out there, but I know like there's some stability conditions too that need to be satisfied. But I think if they're all just like nice meshes, it usually works. Like it's like if you have like really long skinny tetrahedrals or something, it's like kind of breaks down.
I think Gimli might have a solution.
No, it
Right.
doesn't. Sounds good. Well then,
That's it.
that's it. We'll see y'all at 3 o'clock next week. 3 p.m. next week.
Perfect. See you guys.
Bye bye, everyone.